Honorable Retired Mahendra Singh, inspirational thoughts followed by our chief guest Mr. Dharmendra Khajuria, views on various practices in our operational world. It was then followed by keynote speaker Sri Anand Prakash, views on upcoming trends and issues of information technology. Further, we had three technical sessions with variety of research paper presentations.
This was just a snapshot of day 1. Now it's time to start with technical session 4, and for that we have with us the honorable presence of our session chair Dr. Arun Sharma, Dean Examination and Associate Professor, Department of IT, Indira Gandhi Delhi Technical University for Women, along with our esteemed speaker for invited talk Dr. S.C. Gupta, Director Academics and Senior Professor, Rajkumar Goyal Institute of Technology, and we also have co-session chair Ms. Akansha Bhardwaj, co-convener of this conference.
First of all, let me introduce you to our session chair, Dr. Arun Sharma. Sir has completed his PhD from Thapa University, Patiala, MSc Applied Mathematics from University of Roorkee, and MSc MTech CSc from Punjabi University, Patiala. He has vast teaching experience of more than 18 years, and his areas of interest lies in software engineering, soft computing, and database system. Sir has published more than 50 papers in international journals and conferences, which includes IEEE, ACM, Springer, and many more, and also has organized 3 international conferences. He is chairman of Computing Society of India CSI Ghaziabad chapter for 2015 and 16. Sir has also been nominated as Who's Who of the World in 2013 by Marcus USA.
Sir, we feel obliged to have you with us today. Now I would request Ms. Akansha Bhardwaj, co-session chair, to kindly felicitate Dr. Arun Sharma. Please give a huge round of applause.
Next, we would like to introduce Dr. S.C. Gupta, Director, Academic and Senior Professor, Rajkumar Goyal, Institute of Technology, Delhi, who is here with us to share his esteemed knowledge.
Dr. S.C. Gupta, former General Manager in reputed public sector unit and was Founder Director of NIEC, Delhi. He has an experience of 41 years in industry, R&D and academic of professional organizations. He has worked as a director in Northern Indian Engineering College, received 2 Best Educational Institution Awards in North India for excellence in education. Sir has also worked as General Manager in UP Electronics Corporation, Deputy General Manager in Hindustan Aeronautics Limited, and Senior Technical Officer at ECIL. He has worked abroad for 2 years in R&D and industry. He has written 4 engineering books and published 70 research papers in national and international journals. Also provided consultancy in medical electronics and other industry products. Presently working as director in reputed engineering institute, Rajkumar Goyal Institute of Technology. Received international awards, 6 national awards and 2 education excellence awards for outstanding performance such as Opto Electronics Award, Mother India International Award, Bharat Jyoti Award, Rashtriya Udyog Ratan Award, Excellence in Higher Education Award.
So, we feel obliged to have you with us today. Now, I would request students of MCA to kindly felicitate Dr. S.C. Gupta. Please, can we have a good round of applause? Now, we would also like to thank Ms. Akansha Bhardwaj, Assistant Professor MCA RDIAS. Now, I would like to request students of MCA to kindly felicitate Madam. Please, can we have a huge round of applause?
Now, we would like to invite Dr. S.C. Gupta to kindly enlighten the session by sharing valuable thoughts. Sir, please.
Good morning to all of you. I'm sure after last day listening and learning, you are smart again this morning. Okay? Because you are going to learn whole day some new concept, new ideas, the technology of today and tomorrow. You see, my topic is high-speed broadband network for digital India. As you know that today the voice is growing at the rate of 30% per annum. The data transaction is growing at the rate of 50 to 60% per annum. And the internet is growing at the rate of 150% per annum. there is a requirement that the data must be available at instant rate at any time, at any place. For example, if something is happening in America or something is happening in anywhere in the world, we wish to know immediately what has happened there, what has happened, what is the latest, what is going on, what is the latest technology. All this we want to know immediately. So, what is happening? The multiplexing of this voice, data transactions, the internet requirement is demanding high speed broadband network. Now, India has also conceived that we cannot survive without this. So, the BharatNet has been planned by the country. It has started some 5 years back, but it is taking up shape now. What is happening that, next slide please. Where is the, okay, yeah. In the BharatNet, the plan is, the mic system is not required, it is okay? Okay, thank you. The national capital, the Delhi, will be connected to all state headquarters. From state headquarters, for example, Lucknow, Mumbai, Calcutta, all state quarters will be connected to Delhi and they will be interconnected also. Then the state headquarters will be connected to all the cities under that particular state. Then from the cities there are blocks which will be connected to the cities, and then from cities villages will be connected. So that the e-governance, the health requirement, the education requirement, all the requirement of a villager or any person in the city can be met. 35 state headquarters will be connected, 600 districts will be connected, 5,000 blocks will be connected, and 6 lakh villages will be connected. And any person in the village can know what is the rate of the, this ganna today, what is the rate of, pulses in the market, how he can get money from the bank without going to bank. All transactions can be done through this system. This will be coming into existence from the year 2017 onwards. Now the multiplexing I mentioned to you is growing so fast that there is a requirement of information capacity of gigabits per second and terabits per second. The network ring and data structure in advanced countries are working at 100 Gbps, and now the next work is going, research work is on 400 gigabits per second, and which will be enhanced to 1 terabits per second, 10 to the power 12 bits per second by the year 2020. Now this will take care of access network, metro network ring, regional network ring, long haul network. All will be connected with this along with all services. Now this is one example of the broadband DWDM, dense wavelength division multiplexing ring or mesh network. In this, the transmitter, which can have the voice, data, internet, audio, video signals, can be modulated and further multiplexed and sent through optical cross connect to the metro ring, and at the bottom it can be sent to long haul ring, and then it can go to access ring and then passed on to the actual recipient. This is one way, and similarly the two-way can be done where receiver transmitter can be put hand to hand. This is one example of the core metro and regional network. All these business houses, the business cluster, your export electronic zones, etc., the servers, the switch, the data centers, all are connected, multiplexed by the access or metro multiplexers, then send on to CWDM, DWDM, coarse wavelength division multiplexing, dense wavelength division multiplexing over the optical fiber, and then it is sent to the regional ring and also to the long distance network. Now, as I mentioned to you earlier, the growth rate is so fast for voice, data, and internet that there is a need for data transactions. Now, in India, yeah, right. In India, the 98% of global communication is done in the world. 98% of global communication is done using high-speed networking. All the countries are connected by either through sea using optical fiber or through a surface network called terrestrial network using optical fiber due to its reliability. You cannot do, there is no electromagnetic interference, there is no crosstalk, the cost is very low, it is of very long life, 100 years, not a present technology which survives only for 10 years. The network fibers are laid on ground and beneath the sea level between the countries. India is connected to all countries from Mumbai, Chennai and Cochin. MTNL, Reliance, Airtel, Railways, Defence Department have already laid their own dedicated network, but it will be connected to the Bharat network, BharatNet. Government of India is connecting national capital with 6,000 blocks using high-speed network. 20,000 kilometers of optical fiber will be laid in the Digital India project. It is also used in coal mining, various industries. It is used in high-speed networking of communication, used in video and TV signals. Over a single fiber, you can transmit 300 to 3,000 TV channels simultaneously. This is the bandwidth. Now, next. This has very benefit, like as I mentioned to you, free from electromagnetic interference, high electrical resistance. You can let down it with the high power cables. You can have the lighter in weight, free from electromagnetic interference, smaller size and resistance to corrosion. There is no corrosion takes place. Now, what are the trends in this technology? The today, tomorrow and future is based on this technology. For next 100 years will be dedicated to this network. Even your mobile sets which will have a wireless communication of 5G, 6G, 7G are totally processed by the optical waveguide and optical communication at a speed of 10 Gbps. Your all optical communication network will have signal will be processed in optical domain. The everything will be in optical transmitter, the add drop multiplexers, the cross connect, the receiver, the modulators, every will be on a silicon chip or gallium arsenide chip. Multi terabits optical network, as I mentioned to you, it is growing to terabits, 40 terabits, 100 terabits, like that. Intelligent optical transmitter network, it will have variety of quality services. You can have single wavelength for your organization, you can have whole wavelength or in rental basis. Software based services, all the cloud services, all virtualization, everything is now done based on this. This is a next generation network of the world. Ultra long haul optical transmission, ultra long 10,000 kilometer, 20,000 kilometer, any area you can cover very reliably using this, including 10 meters to 10,000 kilometers. Improvement in laser technology, the sources which are laser are now developed as a vertical cavity surface emitting laser is a very efficient laser and it is very reliable. Polymer optical fiber is used to home. Now India is working on fiber to the home. You will have in America 40 Gbps is provided in each home. Every home has a connection of 40 gigabits per second. Now India is also going in the same way. Fiber to the home is being provided so that each room can have a TV, a computer, a telephone, a fax, anything. And then next, your improvement in optical receiver technology, advanced modulation techniques are being used with lot of call stations. Symbols rate is increased, the bit rate is increased, the carrier speed is increased, excellent chromatic dispersion compensation, better optical to signal noise ratio, better spectral efficiency, use of error free correction codes by software, output is also improved. Then there is another improvement in the technology. So this is one of the system where there are three streams. The top one is the data voice is coming on one wavelength lambda 1. The second data transaction is taking place on lambda 2. The internet is coming on lambda n, and some other data is also going into this. Then there is a wavelength division multiplexing. After this multiplexing, you can have a telephone gives only 64 kbps, and then your television, now digital high definition digital television requires a bandwidth of how much, 10 mbps. If you run a high definition TV less than 10 gbps, it will not give good pictures. So like that your multiplexing will take place through WDM mux. You will have an output. Your electrical signal will be converted here to optical signal in this. Once it becomes optical, it is free from any interference, free from any problem. Then this is are the various amplifiers, because every technology has offer some losses. Here the losses are of the order of 0.1 dB per kilometer. Now if you are doing say communication of 5,000 kilometer, 10,000 kilometer, naturally losses are there. So you have to amplify the signal using Raman amplifier and the erbium doped fiber amplifier. These two amplifiers are used together so that it's a uniform gain. And then here it is demultiplexer, and then you retrieve from here audio data, the audio signal, data transaction, internet very clearly without any interference. This is a long distance, that was a short distance, that was a concept. This is the actual system. In actual system there is this is a video, audio, data, there is the internet, all are mux here, then there is amplifier. Then in between it is found that as the signal processes, there is a dispersion also takes place. The signal disperses and the pulse width broaden. Instead of nanosecond, it becomes broader and broader and broader. So to take care of that, there is a dispersion compensation module, DCM. Each amplifier will also have dispersion compensated module, so that your original signal is retained. This is for 1500 kilometer, and similarly you can go up to more. What are the basic components in this optical amplification? By erbium doped fiber amplifier or Raman amplifier, coarse WDM, dense WDM, forward error correction, optical networking using optical add drop multiplexer, optical cross connect, advanced modulation formats. Now this I am telling you that how the two amplifiers are used together. The bottom one is a Raman gain. This is the Raman amplifier, and this is the EDFA. In EDFA, what happens that as the signal processes goes ahead, the level of signal goes down. Whereas in Raman, it keep on increasing, so you get a constant total gain over long distance. You see, hardware and software goes hand in hand. If you don't have hardware, you cannot use software. So these two things are necessary. This is the WDM concept. In dense wavelength division multiplexing, you have a spacing of 25 gigahertz between the two wavelengths, whereas in coarse wavelength division multiplexing the gap is more, up to 2500 gigahertz. Sorry. Next is this is the forward error correction. Some bits are lost and the bits are injected. Some bits are injected extra to take care of losses. This is the principle of coherent detection. What is happening when you work on 10 gigabits per second or 400 gigabits per second? The signal is very weak at the receiver end. So the coherent detection is used. There is a local oscillator is used, which is mixed up with the received optical signal, and the main signal is giving the gain by this coherent detection, and this is a must. This is a must when you work at 100 Gbps and 400 Gbps. These are the various components used in 100 gigabits per second. PDM stands for polarization division multiplexing. QPSK is a quadrature pulse shift keying modulation system. And various components used here are two coherent lasers, receiver and transmitter, Mach Zehnder modulator, drive amplifiers, photodiodes, polarization beam combining system, balanced photodiodes and DSP modules. Let us see, this is a system which has been made and operational in the world. 112 Gbps, non-return to zero, PDM QPSK transmitter having 10 channels, spaced at 50 gigahertz. This top one is the transmitter. This is the transmitter and this is the receiver. This is the purely processing of receiver signal using the beam splitter. The polarization thing is there, 4 detectors are there, and then it is processed electronically. This is the 400 gigabits per second communication link. Here the modulation is changed. From QPSK it is changed to quadrature amplitude modulation, where constellations have been increased to 64, which I will show you. And then the receiver is the same. It is a coherent receiver. Okay. This is the DSP, digital signal processor used, which will have transmitter DSP, similarly receiver DSP, symbol mapping, software programmable modulation coding, RF driver, electro-optic pre-compensation, dispersion, nonlinearity compensation, pulse spectrum shaping. These DSPs are specially designed, and that is how we have achieved 100 Gbps link, network link, and 400 Gbps network link. Now let us see, I am close to my talk. You see performance. Now we have used polarization division multiplexing, 16 QAM, quadrature amplitude modulation, at a bit rate of 100 Gbps, 200, 400. As we increase the gigabits per second, the requirement increases. For example, symbol rate increases to 16, 32, 64. Bandwidth between the two pulses are increasing. The spectral efficiency is also increasing from 4 to 5.33. Signal to noise ratio optical is increasing from 16 to 22, and then this is at 10 to the power minus 3 bit error rate. This is at 10 minus 2 bit error rate. It is slightly lower. Now if we increase for 64 quadrature amplitude modulation and use 200 2 times and 400 once, the technology due to change of technology, the grid spacing has become here same. Here it is reduced for 50, but the signal to noise ratio is increased, and the spectral efficiency is also increased. So to achieve this, you have to improve the technology continuously, and once you increase the technology continuously, then only it is possible to achieve this. This is the various rings which are connected each other. The two small interconnected WDM rings. One is this, two is this. This is a big WDM ring used in regional and national network. This is the cross connect clusters are there, which is interconnecting all these together. Then this WDM chain is going to the access network. So like this it is done. This technology is very cheap, very reliable, has a very long life, free from interference, and all the software technologies now, next generation network, this is called next generation network, and in this all software is combined, all, for example, your cloud computing, any service, virtualization is done through this. Now recent trends are to develop 400 Gbps and 1 terabits per second network based on Ethernet standards. The 400 Gbps will emerge in 2017, and 1 terabits will emerge in the 3 years after, that is 2020. And then you can, these are the various references which have been used in this, and thank you so much. I welcome any question on this, please. You see, when you use any computer, hardware is there. Similarly, because of multiplexing of all these, voice, data, and internet, and audio, video signal, text, and all, the bandwidth requirement is increasing drastically. So therefore, there is a need of a new technology, and this technology is developed especially to meet this demand at a very, very reliable rate, 24 hours, 365 days, all weather. It will work reliably and satisfactorily. Thank you so much.
Hello, good morning, sir. It's not my question. I just want one suggestion with you. As you said that we have to increase technology day by day continuously. Okay. If I increase our technology, we reach them means at the last person of the India. Okay. But how can you change the mindset of the person?
Mindset of the person can only be changed by training. By
But-
training, by giving them benefits, and by allow them to use it. For example, a person living in a village needs to do work in his own language, in his own style.
Yes, sir.
So we have to go to that level, and the training program has already been launched by our Skill India program to train. There is 3 days training, 5 days training, how to use fiber to the home. So there is a training is required. Without that, benefits are required. When you will tell a villager that your produce which you are selling today is 100 rupees per ton, will fetch you 500 rupees per ton, he will immediately interest will be created. Because there is a lot of gap between 100 rupees per ton to 500 rupees per ton. So you have to create an interest, and you have to give them training, hand-on training.
But sir, firstly you have to work on that partner, because if person don't know about any technology, they will try to destroy. As firstly some person go to computer keyboard, then he don't know how to tap, then he put hand on like this. So
At present, this is happening. What you are saying is happening, but it will change.
but sir, firstly you have to work on that. As you heard the name of Mahamaya Express, that so much technology is used in that. But yesterday you said that so many things is stolen by person. How can we change that?
It will change. It takes time. Our Indian society is receptive to change. We do not wish to change.
Okay.
So it will takes time. Now the trains which are having high speeds, everybody will like to travel with high speed train. Time has become important. Everybody wants to save time in various things. So it will take time. It is not a one night job. Rome is not built in a day. Building of a Rome has taken several years. So once this is a difficult task, I agree with you. It's not an easy task. All these things will happen, what you are saying, but still it has to be done on a mission basis, on a vision basis. Thank you.
Sir, I have a few queries. Thanks a lot for your presentation firstly. Sir, firstly, India is a country with a population of 1 billion, more than that, 1.25 billion. That estimates to be something like 10 to the power 9. This model you are proposing is somewhat based on a speed which is 10 to the power 6 kbps, right? Rather Mbps, sorry. 10 to the power 6 Mbps. So how do you suppose each person would get a speed of more than 1 Mbps, which is used for the high speed, which is the minimum requirement for the high speed network?
I have shown you in the first slide itself.
No, sir, actually when we demultiplex the signal, it would distribute as you have shown in the slide. If we start with a 100 Gbps system, it breaks down to a 10 Gbps system in Lucknow. And with a state which has, if a city has a high capita population, then how do you suppose that we'll provide the network there?
Actually, this technology, you have to understand the technology. It's only one wavelength. You can send only 10 Gbps. There are 1600 wavelengths will go hand to hand together. On one wavelength, I have told you wavelength division multiplexing. Okay?
Yeah.
On one fiber, you can send 1010 Gbps together without any interference. Okay?
1010.
10,000 into 10.
Okay.
You can send on a one fiber.
Yeah.
And in a cable, there are around 50 fiber together. So you can see how much capacity you can increase. You have to understand the technology. It's a complex technology.
Okay, thank you.
There are so many fibers in a cable. Then each fiber can have 1000 of 10 Gbps together, hand to hand. Yeah, it's not a very simple. It requires at least a lecture series of 15 days to understand all this. 15 days lecture series is required. 4 hours per day to go into depth.
Thank you, sir.
We have spent 40 years on this. Thank you so much. I am really enjoyed my lecture here. Thank you so much for your cooperation. Thank you, sir. I am thankful to the RDIAS for inviting me for this talk, which is very stimulating and very useful to you.
Thank you, sir, for sharing your profound knowledge with us. Now, with an objective of encouraging the spirit of research and innovations, I hand over the forum to the session chair of the event, Dr. Arun Sharma.
Good morning, everybody. Now we are starting the session, and in this session we have 6 papers to be presented. So maximum 10 minutes will be given to each presenter. The first paper is Big Data Solution, Ms. Mankuvar Khurana.
Good morning, sir. Thank you for the opportunity for presenting my paper titled as Big Data Solution. Before I begin, I just my paper, the title itself is quite descriptive of the fact that it's a combination of two words actually, big data and solution. Now, when I talk of big data, the first thing that comes to anyone's mind is data that is big in size. Now, how big? Can it be gigabytes? Yes, if I talk about a couple of years back or even more than that, the data was actually up to a few gigabytes. But today, the data size is not only about the size, the data size has increased to quite a lot, that is to terabytes or petabytes and multiples of that of data. Because today, everything is like data is enormous. If I talk about whether I talk about the online data, the e-commerce streams, everywhere the data is increasing to multiple times and it's like multiple petabytes to terabytes of data. Is big data only about the size? No. We actually characterize big data by the 5 qualities, which includes, that is the volume, which I said this, yes, it's enormous. The variety, it is earlier when we talked about data, we had a data which was just limited to the fact that it was something which could easily be fitted into rows and columns. That was called a structured data. But now with the variety, with the multiple sources of data, whether we talk about the video clips, whether we talk about the images which you use on Facebook or Twitter, anything, it's like the structuredness of a data has gone into something which is called unstructured data or semi-structured data, which is not just limited to something which can be easily fitted into rows and columns. When I talk about big data, the other characteristic that comes into which is characterized by it's the velocity. The streaming data, the online data transactions have increased to multiple times today. The Facebook, just taking example of Facebook because that's something which is common to all and which everyone has heard of actually. So big data is not just about the volume, it's about the variety, the multi-structuredness. And based on this data is actually being used by companies to understand the requirements, make decisions, to find out the hidden patterns and the relations between the data, so that better products or better solutions can be provided to their customers, to basically understand the customer. Like if I talk about a supermarket, like they actually use their video clips or something to analyze the data. For example, it's been quite a time, Walmart introduced the beer and diaper. Now they had this, they from the videos and from certain surveys, they analyzed that when a man comes to pick up a diaper, he buys a beer with that. So to increase the beer and the diaper sales, what they did was they actually shelves of both and beer side by side. So when a man came up to pick up for a diaper, he always bought a beer. So their sales was increased to multifold times at that time. It's been a couple of years for this when the story actually happened. So this was basically analysis. Now this process of analysis is actually called the big data analysis, where you're finding out the patterns, you're finding out the insights of the data that is being stored in somewhere, and you're providing a solution for that. That's what big data and big data analytics is all about. Yes, when I talk about big data, just transforming the data and processing the data is not sufficient. We have multiple components to it. We have interaction, and then we have the analysis. We gather data from multiple sources, the images, the text files, the video clips, and everything. All this data is stored in a component called the big data refinery. This is something that stores your data, aggregates it, and provides for a value for that data that is being stored. And this data, obviously when you have the data, you need to even know about the interactions, the correlations among the data. So for that part, we have the component called that is the big data interactions and your transactions. You transact, you process your data. Once that interactions has been clarified, the data is again the data is aggregated and sent data refinery. From there, based on certain solutions like your dashboards or visualizations, you actually analyze the data to find out what insights or patterns are being shown. Like for example, if I talk about a particular e-commerce website and it's obtaining data from multiple sources. Say for example, if I talk about a hotel's website, it's from multiple further hotel sites. So which particular website is providing for the rates, how cheaper the rates are, that's insights or something where the analysis come into picture. Based on that, the particular company which is actually receiving that hotel's data can decide whether to continue with that site or not, or how to improvise that solution, how to solution. That is something which comes into the everything picture. So the big data architecture is all about that, how are you actually providing for a insight or a pattern which helps in making your better. We have multiple techniques with it. The first, when data is obviously Hadoop is something just Hadoop is like when I am talking about Hadoop, it's not just the only Hadoop which is providing into my entire big data solution. Obviously with Hadoop we are using multiple technologies. Hadoop is something which is consisting of two components. One is for storing, that is your HDFS, that is your Hadoop distributed file system, and second is your MapReduce. Now what MapReduce does is, you have a collection of, it's your filtering, your filtering of your data. You have multiple data, you have scattered data, you're combining the common ones and providing a unique solution for that, so that that particular data is aggregated and it can provide you, when analyzed or when queried upon, it can provide you for a particular analysis or a solution for that part, so that you can study those patterns actually. So that is what Hadoop is. Next we have the NoSQL. When I'm talking about NoSQL, it's not that it is not SQL. NoSQL is like you're adding a complement to your SQL, because when I talked about SQL, it's like structured query language. So it's dealing with your structured data that can easily be fitted into your rows and columns. Now when I'm talking about NoSQL, because today data is so much unstructured and it's varied, that just putting it into rows and columns in a standard that is a relational database, your traditional database system, is not that simple out. So today data is being stored in your JSON documents, your XML documents, in the form of your graphs, your key value pairs, etc. So the multiple databases that have been supporting this have been like MongoDB, Redis, Cassandra. These are data which are actually storing, because today data is so much dynamic in nature that adjusting into a structured form is not that simple as it used to be earlier as compared to that. Ingestion and streaming, it's when I'm talking about big data, I initially said that data is being streamed out, or it's having a high velocity. I mean, the online streaming data is enormous today. So to control that data, to analyze or monitor that data, to store that data into your Hadoop or into any common structure, we have some of the technologies I've mentioned here is like Flume. Flume actually monitors, or I say provides for the analysis of your online streaming data. It stores that, it captures the data from multiple sources, from multiple online sources of course, and stores them in your Hadoop, which so that it can be further be analyzed. Yes, you need add-on technologies for that. Next we have Chukwa. Chukwa is it's an open source. All these technologies are Apache open source technologies. It actually when I was talking about Flume, it was for monitoring your online streaming data. Now when I talk about Chukwa, it's like you are monitoring your log base as something file based data, log based or static data. Obviously something that has been stored in logs, it is used for monitoring of that. And the third one is a Scoop. Scoop is nothing but apart from analysis from daily basis, apart from analyzing your daily basis data, you need at times, or most of the times, there are some historical data which need to be analyzed as well for actually finding out the patterns or the insights of the data. So, and at times there is your data is stored in your relational databases system. So to provide for that, Scoop is a technology that is used for transferring your bulk data from your historical relation system to your Hadoop system and then making the analysis accordingly. Real time, again, it's real-time querying is again some technology like HiveQL. Impala is a technology that uses a query language, that is HiveQL, for analyzing or querying your data that is stored in your Hadoop. So these are Spark and Impala are some of those technologies. The architecture that we discussed was even today, like when we talk about big data architecture, multiple companies are providing for solutions, big data solutions actually. We do not have a generic solution as such. It's like multiple technologies. We have, just 2 minutes, last slide actually. It's just like that we are in this, what we're doing in this diagram itself, that we have obviously collecting data from multiple sources that being stored in the big data refinery. If I talk about today, we can use the Hadoop as a big data refinery. Again, this big data refinery is interacting with your transaction and your intelligence analytics components, and based on those, we are analyzing your data. If I talk about today, we are using the technology like Hive, NoSQL for querying and analyzing of data. But at the end, we need a solution which is generic and serves all the components, all the requirements of a particular customer actually. Because today we are assembling these components and providing for a solution. Rather, we need to design a common platform for all of this. Something that can easily handle your multi-structured data, provide for insights and your hidden patterns. Thank you so much. Yes, sir.
How do you differentiate mining with analytics?
Sir, somewhere it is similar, no doubt. Mining is doing your analysis at the end of the day, but because what what I have studied, and all, it's like the time consuming in terms of mining has been more in terms of what the figures have shown in the past experiences.
Thank you.
Thank you so much.
It's a request to the remaining presenters that be focused on your proposal basically. Don't go into too much details in introducing the topic because we have short of time. Next presentation is a review of classification techniques in healthcare data mining. Ms. Saeed, Hina and Rabi.
Good morning, everyone. Good morning, everyone. My name is Said Hina, and I'm here to give a presentation on my paper entitled as A Review of Classification Techniques in Healthcare Data Mining. A brief outline of my presentation includes introduction to data mining, classification techniques, followed by applications, and then the conclusion part. So giving a brief introduction about my topic, about data mining. Data mining came into existence in the middle of 1990s and appeared as a powerful tool for fetching previously unknown patterns or knowledge from huge amount of data. Data mining is basically a part of knowledge discovery in database and is actually a process of mapping low-level data into more concrete, abstract, and useful patterns. And in other words, we can say it's a process of transforming the large and incomprehensible data into understandable descriptive data. As we can see from the diagram, these are the steps that we follow in knowledge discovery and in databases. The first process is that, can I take this? Okay. The first thing is we take the data from any source, that is called as data extraction part. In this, what we do is we keep into consideration the target data that we have to on which we have to do the analysis, and then we do the data preprocessing. In data preprocessing, what happens is the data that we have taken, that we have selected actually, we preprocess it such that in order to construct a good model, because in order to construct a good model, we need good data. For that purpose, we need to remove all the anomalies or the missing data that are present in our data. So after that, what we do is we focus on the feature reduction process, that is transformation of data. Here what happens is, like all the features that we need in our for our target or for our like whatever we want to have whatever we want to have the analysis of, we'll take that data and only those features. After that, data mining. Data mining is the core of this whole KDD process, in which we construct a model that will convert the data into the useful information. After that, the interpretation, like that is used for accuracy checks like true, false, positive, true positives and true negatives. Then followed by classification techniques. Classification is one of the data mining technique which finds a model to distinguish between data in order to classify it into respective classes or concepts. So in classification techniques, what we do is firstly we build a classifier, and then we use this classifier to classify our input data. Like we can see here, whatever will be the input data, we divide it into training data and then the testing data. In the first scenario, what we do is we take the training data and apply some classification algorithms onto it and build a classifier or a model. And then what we do is, in the classification algorithms, we have used various classification algorithms like naive-Bayes, k-nearest algorithm, and so on, and then we build a classifier model. In the testing data, what we do is we take the data and apply the classifier onto it and see whether it's correctly able to classify the data or not. Some of the applications of data mining, since it is considered as an important interdisciplinary in IT, and it is useful in various domains. For example, market analysis and management, corporate analysis and risk management, fraud detection, education, and healthcare organization. And my paper focused clearly on healthcare organization. Uh, healthcare data mining. Okay, healthcare organization is the largest and the fastest growing field consisting of huge amount of data. The traditional analytical tools were not sufficient enough to extract from the data available. So therefore data mining technology is one of the vital and motivating area of research, providing benefits to healthcare organizations for grouping the patients with similar health issues in order to provide them effective treatments. And now a major challenge that healthcare organizations are facing is correct diagnosis and effective treatment to patients. Poor clinical diagnosis certainly lead to disastrous consequences which are unacceptable. Data mining techniques such as clustering, association, regression, classification, and prediction, etc. are available and can be used by healthcare organizations. My paper actually aimed at the various classification techniques that were applied on the medical databases like cancer and heart diseases. The diagnosis of diseases using data mining application is an intricate task, but it considerably reduces the human effort and increases the diagnosis accuracy. It's also believed that if we combine these various classifications, we can actually predict diseases in healthcare sector very efficiently. Thank you so much.
Again, any question? Again, I have the same question. Why not it is analytics in healthcare? Why it is mining?
So because this extracts data in a very efficient, because we have various algorithms into it which can extract
We have
data.
the same algorithm in big data also, because big data also needs some refinement, noise reduction, classification, clustering, so many things we use in big data also.
Okay.
Now the trend is changing from say big mining to analytics. So can we use analytics in place of mining in your case? Or is it entirely different thing than big data analytics?
So like normal analytics or big data, like you're saying that why not applying big data on this? I don't know. Thank you.
The next presentation is on speech recognition and synthesis. Mr. Parth Nagar, Mr. Labhansh, Ms. Himanshi Mehra.
Thanks. Good morning, Chair Sir, teachers, and my dear friends. I am here to present my topic, speech recognition and synthesis. So, as we know, speech is a very important part of our communication basis. The basic fundamental speech recognition, as we know, or what we call as automatic speech recognition, is the process of recognizing any audio, voice, or speech, what we call, via machine into text or any other form. This is what we call speech recognition. So it's often annotated with the word speech to text. There are four types. The physiographics of a speech system are basically of speaker independent and speaker dependent. Speaker independent system is one which does not require any particular speaker to train the system, while a speaker dependent system is one which focuses on a particular speaker's voice and his pronunciation to the various text. Then there are three more physiographics, that is isolated, connected, and spontaneous. Spontaneous, as we can easily connect to, is via simplistic talking manner. When we convert speech to text is known as spontaneous, while connected or isolated systems are those wherein a single word is either translated once at a time, or multiple words are translated at a time. This, as we know, this is the basic components of the speech recognition system. The front end composes of a feature extraction module. Feature extraction basically implies when we convert the analog signals that we speak into various samples via the frequency sampling process, that is taken care by a sampler which works at a very high frequency of some 1000 megahertz, or what we call gigahertz. Here in the recorded speech samples are sampled by the sampler, and we create a feature vector which is basically a digitized discrete, rather not digitized, a discrete entity which has the parameters of the sound, like the tonal stress or the phonetic transcription media it uses. Then the most important part of the whole process, that's decoding. Decoding finds the best fit for the sound to the text. As we use two models, one is the acoustic model and the other is the language model. The acoustic model is basically focused on transcribing words on the basis of their phonetic transcriptions. That is word to phoneme, and phoneme being the basic unit of our language, the vocal language basically. It uses techniques like dynamic Bayesian networks, and the most important one is hidden Markov model that focuses on a random process for a short time and predicting what the outcome would be. Language models are basically used when we try to convert the linguistic words into the spoken words in their linguistic written form. Pronunciation modeling, it basically is a modulation wherein we use the pronunciation of the speaker, his stresses on various phonemes to actually know what expression he's trying to give up. Approaches, there are three approaches: acoustic phonetic approach, pattern recognition, artificial intelligence. Acoustic phonetic uses basically rules. Pattern recognition as an approach is wherein we use a training set and try to bring out an outcome from that. And artificial intelligence is the new gen technology wherein we use neural networks and various advanced training set like deep learning, which is based on neurosciences. This is a schematic of that process wherein we get the audio, feature extracts at the front end. We use a decoder with the acoustic and the language models, and we get the word string. Emotions play a very important part in our speech recognition process, just because of the fact that sometimes while speaking, our emotions cloud our text. Say, for example, if I am speaking now, I am full of anxiety. So if I try to convert this into text, it would be flawed in some manners because my emotions would cloud the system. Then there's the conditions influence on the process. If there is a clean training environment, the training environment basically is the system wherein we try to train the system to a particular speaker's voice, or in case of a speaker independent system, to a general audio context. If it's clean and we are working in a cleaner environment, the speaker is speaking in a cleaner environment at the same time, then it's a very highly efficient process. But if it's not, then it's a low efficiency process. Then the same goes for the noisy system. There are basically two types of systems: speaker independent and speaker dependent, as I told earlier. Now there are two more categories that have come up. That's the speaker adaptive system, which basically models on the speaker independent system and adapts to a particular speaker's voice on the basis of a training set that is provided on prompt 2. And a massively speaker independent system is one where we collect large amount of speaker database and modulate it at the same time to train the system. Where it can be used, it's a basic dictation, although we shouldn't exactly relate the word dictation to voice recognition, but dictation as a whole is an advantage of voice recognition. system control, navigation, commercial and industrial, voice dialing, as we all know, and in aerospace, in defense, it's used, wherein recently our HAL used it for autopilot, on command ballistic missile launch, and then there are advantages for people with all could comprehend with that. Organizations use it to productivity by making the automation process more efficient. Disadvantages are basically it's not possible to build a perfect system. That has been there for studied at ideal system is not evident. Our conversations actually are very difficult to translate to text because of the fact that text our communication has non-verbal gestures, our communication has stutters, our communication is filled with emotions. Then the speech synthesis part. So speech synthesis is basically the reverse of what speech recognition is. Speech synthesis as a whole implies that we translate a particular text to sound. So it's TTS. Speech synthesis basically has two basic fundamental sections: for and concatenative speech synthesis. Concatenative, as the word is clear, it is used by addition of words. Formant is based on the formation of the words. So when we build a TTS system, the basic process is we use text and we have the framework of the synthesizer. So when the framework actually includes the front end and the back end, the front end being the text normalizer or the preprocessor, wherein we convert the text into prosodic features like clauses, words, and phrases. These are forwarded to the phoneme, word to phoneme, or what we call a grapheme to phoneme translation, and we produce the and we translate the transcriptions to the words to the transcriptions, and these are forwarded to the waveform producer or the waveform generator, what we call, and we get the speech. So as I was telling, linguistic analysis has three parts: phasing, intonation, and duration. Phasing implying when the speech would be delivered, intonation how stressed the words would be, duration for how long they would be stressed. That basically creates the transcription to the level of waveforms, and by the generator we directly get the waveform, which is the speech. We and while I was talking about concatenative speech synthesis, concatenative involves three types: unit selection, which is we select a word at a time and we try get the transcription of that particular word in order to generate the waveform. The second one would be diapheme translation. Diapheme implies basically phonemes to the translations of one phoneme to the other is called the diapheme translation, and a domain specific translation, which is very specifically used for a particular domain, like we have on the metros, the speakers of, just a minute, there are emotions as well in synthesis. See, it's often said that in when we are synthesizing a voice, then the one who is hearing that voice, synthesized voice, can easily comprehend what the emotions are. So emotions in synthesis are as well as are a very important part in the process of synthesis, and the impact of these on the society is basically it helps in the training of visually uh, people with hearing disabilities. Then we could find out hearing disabilities, and the rest was taken care in the recognition part. Thanks a lot. Thanks a lot.
Next presentation is on the topic a framework for implementing trust in cloud. Mr. Sanjeev Saxena, Ms. Natasha.
Okay, good morning everybody. Yeah, this is the research paper which I have developed on the basis of my industry experience as well as on the basis of the academic experience that I have. And the topic is a framework for implementing trust in cloud. Then this is just the introduction which highlights the importance the cloud computing is gaining nowadays, right? It is widely accepted by several business units across the globe. The main reason is the fact that it helps in lot of cost savings, right? Capability to provide several benefits to the business organization such as savings on the cost maintenance of hardware and the like, right? This is all as we know about what the cloud computing is and the benefits that it accrues. However, despite these several advantages, there have been issues such as data leakage and other things by the service provider who are assumed to be the custodians of the data with the organization trust while giving the contract to the cloud service provider, right? For the customer who avails the cloud trustfully, hands over the data which is confidential, and if that data gets leaked out or there been some compromise on the data or compromise of the data on the part of the cloud service, then their questions come respect to the survival of the business unit, right? In other words, it boils down to the issues related to demonstration of degree and level of trust. Two things are important: degree and level of trust by the service provider, because whenever someone hands over the data to another person, then it is the degree of the trust which counts and which is taken into account while giving the contract. Then this is just facts and figures that supports that how the cloud computing has gained tremendous importance and the impact on cost savings that has come into the picture, right? As we can see that capital investment, the cloud, it is always zero. Most of the times it is zero, but then it depends upon what other things you are availing. Then setup costs $1,000. So this is all the facts, and there's been the source from which this data has been compiled. Then this is just the structure of the cloud, which highlights that there are three main components of the cloud: SaaS, PaaS, and IaaS. These are the things which the cloud is basically developed. IaaS is infrastructure as a cloud, right? Infrastructure as a service, sorry. Then PaaS is platform as a service. SaaS is software as a service. And why the term service has been attached? Because the client is paying for the amount which he is consuming, right? Then reason for choosing IaaS, because this paper has been developed at the IaaS level. Then these are the reasons, and the component which we have taken at the IaaS level is the server hardware, right? Why the server? Because lot of data is stored on the server, and most of the data manipulation and other things get leaked out from the server itself, right? Then we move on to the approach to the development of the paper. The development of the paper follows a structured approach. That means this is the structure which we have adopted for developing the paper, and in that we have first defined what is trust, what is general data, what is organizational data, what is confidential data, and what is trustworthy data, right? Because this is essential, because data, lot of and various types of data is stored on the server. It may be a generic data, that means which is available to the public, such as the website data. Then it is the organizational data, that means which is available to the particular section of the organization, or it may be applicable to the entire organization. Then confidential data, that means data related to commercial and finances of the organization and other things, with data which may not be applicable to the entire organization. That means they are restricted to some particular segment of the organization, right? And the reason for choosing it, it is the practical implementation of trust component, right? Demand of the market based on the market dynamics, right? Or the business scenario or environment, type of business operation performed by the business unit. That means everything is dynamic, as IT industry itself is dynamic. So that is why we have taken this thing for the dynamic purpose. Then this is the framework. The data which is entered, what we are doing, what we have covered in this paper, when the data is entered, at that point itself we are ensuring that data is captured and it is classified, whether it's an organizational data or confidential data or other thing, and how that is limited to the trustworthiness, right? Classified according to the means and manners it will be used in the business unit, right? And this can be changed. This is not permanent. This can be changed. Then this is a snapshot of the framework, and it is giving you the examples also what the framework is all about. For example, this cloud component is IaaS. Then sub cloud component is the server. That is the particular hardware we are accessing, right? Whether it is the server or it can be any other component. Server type, that is Citrix. Server ID, that just a notification. Then location, server installation date not known. Client ABC XYZ Enterprises, right? And data type, ABC, the data that is general data, organizational data, confidential data, and trustworthy data. That is the data type which has been explored. And again, XYZ Enterprise is always storing only organizational data and confidential data, right? Data access mechanism. This is very, very important, because if you don't have access and some other person uses that access to exploit that data, then it becomes difficult to build that trust. For ABC, general data is open to all, right? Organization data is open to CFO or VP or CEO or whatever, and then confidential CEO and CFO. That means the other level of the hierarchy who can access this data, and if there is any other variation, then that can be easily pulled up and see where that trust has gone, what type of data has been accessed, and so on. Then trust type, performance related, server uptime 3 minutes. That is the service level agreement. That means particular report has been generated, which itself is demonstrating that the service provider is adhering to the trust. If we say that server uptime would be within 3 minutes, then what would be that time? That server maintenance time 6 hours. Within 6 hours it is up. Then that degree of trust and level of trust is being demonstrated continuously by the generation of these types of reports. Then the same thing we have implemented in the form of a mathematical equation, where trust, PQ are the various parameters, that is whether general and other things, and alpha, beta plus gamma is equal amount of significance. That is also very important. A data may be confidential, but it may not be that much confidential. So that is the amount of significance. That means, in other words, it is the weightages that we have provided to the trust component which we want to evaluate. And then that's another example which we have quoted in the paper. Then limitations of the paper. The limitation is business model vendor may follow totally different approach, right? Client may go in for PaaS and SaaS along with IaaS. That is a different approach. May not be applicable. Some of the trust components may not be applicable. Client posts general data on the client server and the config on its own server. Then how to integrate this, and so other issues of the limitations of the paper. Then feature scope is integration of various types of servers for those organizations which follow multi-locational development concepts, right? Integration with smartphones and other devices, and operation with internet connectivity is again a limitation on the part of cloud service provider. That's
I have a question. Who will you can say implement this particular framework? The cloud vendor or
the cloud vendor. The cloud vendor will implement this particular framework in consultation with the customer.
So it means he'll share this particular document, this framework.
He will share. He will say that this is my confidential data. This is organized. That means the customer will tell the cloud vendor that this is confidential data. This is accessible only to CEO level or CFO level or to any other level, and that way he is going to demonstrate that trust by generating reports, whether he is adhering to what he has been saying or as per the terms of agreement or contract.
And on what basis this alpha, beta, gamma will be decided? Whether it
That
is
would be
0.25?
decided by the customer, because customer knows what data is important, what is the degree and level of importance as is applicable in the business processes.
So it will vary for
It will
every
vary for
customer.
different type of customers.
Any other question from the audience? Thank you very much, sir. The next presentation is on the topic ethics of high order mining technique for business development in smart cities. Ms. Zeba.
The amount of data is going beyond zettabytes and yottabytes, unquote. A very good morning to one and all. Today I, Zeba Rahman, is going to present before you a research paper on the topic ethics of high order mining technique in the development of smart cities. In the modern era of science and technology, as we all know that the amount of data is increasing day by day, and with smart cities in countries like India, where social networking sites or say Facebook, Instagram, on every day basis, minute to minute data is increasing, we really need to understand the relevance and the importance of the data that we have. It can be prime data or it can be non-prime data. Prime data is basically the data that comes from, that is the direct data from the source, and non-prime data is in consideration to apart from what is not the prime data. So in this particular research paper, the purpose has been to utilize the rules and patterns with the 18.5 as expected amount of data that we have available, to use it and use the high order mining technique after the first order, second order and above high order mining techniques that have been applied. It is the most precise and the most accurate form of mining technology that we'll be implementing on the data we have with us, and this will help countries and to develop and understand the process of business that can be used, for the understanding of the competition in the market. Like the graph here shows that starting from 2009 up to 2020, it is expected that the amount of data will be 50% of what it was in 2010. Starting with the research paper, we have assumed certain we have got certain hypotheses that were that we the with the amount of data, if it is after the high order mining that will be attained, it will be much more reduced volume, and thus mining and understanding of the business will be more faster. The second point states that the development and maintaining of the algorithm with different companies and different organizations can be utilized as an amalgamation, as a togetherness with different approaches and techniques to be shared. The third point suggests that the facilitating of the combination of different data mining strategies can be implemented using various combinations. The research paper that I have written is has been previously done by some of the related works by eminent researchers, and they were basically what they have concluded from their researches has been that they have found the longest temporal interval with different association rules that will be used for the variables in the data mining technology, and the evolution of the statistics that will be used for the association rules in the mining technology. They can be algorithms which can include, that can be temporal based, that is timely, and thus they hold the relevance. Now this research paper has a generic model of utilizing the like I have mentioned, the amount of data that we have with the designed framework after the first order, second order mining and the other high order minings. The upmost and the most upgraded high order mining technique will be more able to precisely be available to the business organization to understand the customers. For example, if we have, for example, I'll quote an example here to understand it in much more precise way. For example, the shopkeepers of any locality or of any marketplace, they consider to open for it is like a market basket analysis that has been done by them with several association rules that states that they consider to open their shops or their stores on the weekdays, since they are working people in the hours that are where more customers will be available to them, rather than on the weekend days when the people have a tendency of getting up late and having late night hangout places. So the number of the amount of duration, they know that the best customers timing that will be available to them for the customers to get into their shop and buy the products in their store. Here I have we've started with the notion of high order rules to understand how this high order technique works. There is an example here. We have taken six association rules with different trend analysis, with people with high income having the number of children and a car owner. It has a statistic and a consent associated to it. All these six association rules are all together taken, and then we have performed mining from starting from the first order, then the second order, and subsequently leading towards the high order technique. Now, how we get the high order rules from the first order rules? It first says that the high order rules have to be carefully implemented from the first order and the other higher order rules for knowledge discovery. And in this figure that I'll just show you ahead, it includes trend analysis as well as association rules. Trend analysis is basically analysis done on the data that organization has over the time, and association will be the variables that the data will be including. We try to relate those data and find out the best result from them. The figure I was just talking about, this is that diagram that shows the trend analysis and association rules. Here I have quoted an example of association and to explain how association clustering and how characterization all together will be utilized in the trend analysis as well as the association of the data that will be available. Now, starting with the high order mining technique, we have a general framework which starts from the first order, which has a one-on-one relationship with all the variables in the data. Then subsequently proceeding ahead one by the other, we'll reach to the high order rules and finally to the high order mining technique, that is the upmost in the diagram, as you can see, based on the time sequence available. The steps that we will be following for the high order mining technique will be using the first order rule in such a way that we'll have certain questions that includes a rule that how the sessions of mining will be related to each other. Then after that, the next step will be we will group on the basis of the time series. We'll be grouping all those rules that have been we have achieved, and subsequently the aspects of the rule analysis will be utilized ahead. Modeling of the first order rules. It basically the equation that you're just seeing on your screen, from starting from A1 going up to AN and followed by the C1 to CN. These are the association rules, and they are all directly associated with the clauses that an association rule will be available for the data. The first order rule will be a tuple, and it will include two basic parameters. First will be a rule content and the other one will be statistics. The rule content and the statistics will be all together be used for situations like market basket analysis or examples that I just quoted before. The statistics that will be included for the first order rule will include support, confident, and chi-square. Chi-square is basically a term used in statistics that helps to understand the distribution of the variables in the data we have. Then the another definition of the understanding the mining sessions for the first order rule will be a 5 parameter equation that will include session type, timestamp, data setting, statistics settings, and R. I'll be explaining you what all these 5 parameters will be. The session type will be all the association rules that we'll be having. The timestamp will be time at which the data is being analyzed. R will be the first order rules that we'll have. Settings will have specification about the transactions, about how one event of the data will be related to the other. And this data settings will be having the transaction inspected in the mining sessions. Query setting will be the issuing of the original data to extract the transaction of the relevance of the data that is available. Now, we have in the first order rule itself, we have two consideration, lemma 1 as well as lemma 2. Lemma 1 will be all about the different association rules. Now we will be subdividing them into a smaller and presented as small r, and all together they will be combined together as r. Then subsequently we will be using different temporal settings, and different definitions will be available to us. I'll be just taking another more 5 minutes and I'll be just concluding with it. We will have with that we'll have different conditions of how understanding the temporal sequences. Going by the law, like I stated, lemma 1 and lemma 2, we will be associating the rules with the times and will be all together doing it. Now the issues that will be encountered will be that the different data settings will not be able to be arising from the different mining sessions, and the second issue will be sometimes the first order rule will be comprising of the second order rules itself. So it's not necessarily that because it might be varied because of the timestamps, and these will be all the issues that will be available after during the high order mining technique that will be followed. Now the future scope will be, it will help the other companies or organizations to use the data and attain a competitive advantage over the other. It will be the most reduced and the most filtered amount of data that will be available to the companies, so that they can understand the market and attain, help them, their association with other organizations to develop. If the company will develop, of course the city where it will located, it will develop. These are certain references that I have taken. Thank you. That's it. Any questions?
Google's project solution, radar-based gesture recognition to wearable devices, Ms. Neha Gambhir and Ms. Ghazal Bhatnagar.
A very warm and delightful good morning to all of you. I, Neha Gambhir, and my partner Ghazal Bhatnagar, student of MBA from Northern India Engineering College, would like to thank first of all RDIAS for giving us opportunity to be here. We are going to present a paper presentation on the topic Google's Project Soli. It is based on the gesture recognition. First of all, I would be covering the introduction about the Google's Project Soli, then the working of the Project Soli, and afterwards the positive and negative aspect, and further I'll be covering the future, and I'll be concluding the topic. Project Soli is a new endeavor from the Google's advanced technology and project sector. Hopes to revolutionize how we interact with the technology, called the Project Soli, that provides a type of motion controller that uses a radar which picks up the movements in the real time and uses these movements to alter the signal. Basically, it uses a radar technology which recognize our gestures. The radar sensor is smaller than a fingernail and can be embedded in virtually anything. Project Soli is using radar to enable the new types of touchless interactions, one where the human hand becomes unnatural. The Soli sensor can track the sub-millimeter motions at a very high speed and accuracy. It fits onto a chip and can be used inside even smaller wearable devices. First of all, the Google project has focused on the smart watches. Next, I will be covering the working of the Project Soli. The Project Soli tracks our gestures that detects the objects in the motions through high frequency radio waves that takes a fundamental different approach to the motion tracking. Soli's sensor captures the motions up to 10 frames per second and are more accurate than the camera-based system that track motions at much lesser frame rates. These radar can pass through the certain types of objects which make the technology more adaptable. One major disadvantage that the user had with the camera-based gestures technology are that in the condition of the poor light and when the obstacles are placed in the cameras, we are not able to track the motion, making the gestures recognition weak. This radar technology gives the higher accuracy that is not possible with the camera. The project lead for the Project Soli primarily talked about the Project Soli in the context of the smart watches. We'll cover this working through this video. You will understand it
radio
better.
frequency spectrum, which is radars, to track human hand. The radars has been used for many different things. To track cars, big objects, satellites and planes. We're using them to track micro motions, twitches of human hands, and then use that to interact with wearables and Internet of Things and other computing devices.
Our team is focused on taking radar hardware and turning it into a gesture sensor. Radar is a technology which transmits a radio wave towards a target, and then the receiver of the radar intercepts the reflected energy from that target. The reason why we're able to interpret so much from this one radar signal is because of the full gesture recognition pipeline that we've built. The various stages of this pipeline are designed to extract specific.
The Evan is the founder of the Project Soli, said that it can work through the materials. It can be embedded into objects. It allows us to track really precise motions. And what is the most exciting about it is that you can shrink the entire radar and put it into a tiny chip.
A very good morning to one and all. I will be covering the positive aspects of Project Soli. The first positive aspect is the Google team is hoping for the Project Soli technology to be used in reality gaming. The next is the technology is incredibly intuitive and precise, being able to interpret even the slightest movement of the human hand. Already there are cameras that work in a similar way to the radar chip. They are very large and their accuracy can leave a lot to be desired. The Project Soli team found compressing the technology into a small enough form that it could be embedded into a chip to be their biggest challenge. The portability and small size of the chip is a massive benefit to users, and both those using it for personal and entertainment reasons also. The negative aspects is the specific gestures are to be remembered by the users. If those specific gestures are not remembered by the users, then this technology is of no use. Since the technology is new, the cost is very high. The setup cost and the other and for users to learn this technology, it is very high. And time consuming, as this technology is new to users, so they will take some time for learning this technology. As for this use within classes, it can be a distraction for the students, as this technology is new and most students will be very curious to know about it. Next, the future prospects of Project Soli. Currently, Soli is demonstrating with wearable, but interaction with the Internet of Things or other computing devices or other is not out of the realm of possibility. This can be, of course, be applied directly to 3D modeling and sculpting in software. ATAP is Advanced Technology and Project Group, which says manufacturing the device can be easily scaled, as it is very possible. Consumer electronics of the future, from televisions to mobile phones, to microwaves to toasters, could be fitted with this new chip to capture the fineness of human touch. Now, the conclusion will be done by Neha.
Further moving to the conclusion part, the ATAP, that is the Advanced Technology and Project Groups of the Google, also achieved the scale of production and did it all within the 10 months of the development. Now, after focusing on the smartwatches, they are moving towards microwaves, televisions also. They want a sensor which detects your gesture movements and your technology will be start working. They also figure out that how to track the minute changes in the received signals to determine the position of an individual finger. Soli is being targeted for a broad availability later this year in the form of that usable in wearable devices like the smartwatches. This could seriously help to improve the chops of the Android Wear hardware, as if it will become and it will be successful, then the Android technology will be isolated. These are the references from where we gathered the data. Thank you.
Is it available in India for research purpose?
So actually Google is at present working on this project. This project has not been completed yet, but it is working.
For production, it's true that it's not available. But for research, is it available?
Yeah, data is available for the research.
Thank you, sir, for pioneering the session. Would you like to say a few words?
Yeah, I would like to congratulate all the participants who have presented their paper and presented their papers on very latest topics like wearable technology, cloud computing, and big data. My only suggestion is just we are describing the technology. We are not doing any extraordinary work in research. Basically, we are using the technology which have been developed by not by Indians. So we should start working in devising certain some new things for which we can feel pride. So papers are very good, very informative, very knowledgeable, but the point which I feel that it is missing, that is our contribution to describe a technology. Yes, it's good thing for a start for the students, because for some of the students it may be the first paper, but now it's the time that you have gained some confidence that how to write a paper. Now start working towards, say, implementation part, where you can use certain algorithm, you can improve certain algorithm and can get better result. Overall, it was an interesting and fantastic session. Thank you.
Thank you everyone for such a wonderful session. Indeed, the session was full of zeal and valuable knowledge, and kudos to the participants for their work. A big thanks and appreciation to the session chair. Sir, your feedback and insights have been noted down by our presentators, and we look forward to see you with us in near future as well.
In order you to cherish the memories of this session with us, I would like to request co-session chair to present the memento to Dr. Arun Sharma. Thank you, sir. Ladies and gentlemen, now it's time for break. Let's proceed to the ground floor hall for high tea and we shall meet after half an hour and continue with the technical session 5.